Hey everybody. Today we're going to continue with our Chef Habitat package for our Golang Hello World example. Last time we learned how to create a plan file for this application. We built this plan file from scratch and we learned that the plan file is the basis of a Chef Habitat package. It contains important metadata such as the name, the version of the package. It contains important information such as the build time dependencies. It also contains important information such as within the artifact where the binaries exist, and hence what directory needs to be part of the path. And it also defines information such as what are the steps required in order to build the binaries and later copy the binaries into a specific place in the final artifact. We also created a run hook from scratch. We learned that without a run hook, our package cannot actually be loaded as a service. It stays a binary package like the Git habitat binary package or the curl habitat binary package. But with the run hook, we can actually load it as a service and have the Chef Habitat supervisor manage the process as an orchestrator. Today, we want to add health checks to our application. The reason why we want to do this is later when we create more complex applications that can have different health statuses, we want to be able for Habitat to understand what the health of our service is. Later, when we deploy this service to ShuttleOps, we'll be able to see a health percentage. We can see if it's absolutely healthy. We could see if several components in the environment are healthy. And without the health check, we would not be able to do that. In order for us to add a health check, we need to add a health check hook. The health check hook sits next to the run hook. It is also a bash file. It is a bash script, and it has one of four exit codes. So it could exit with 0, meaning that the status is okay. So if you had a health check endpoint and your health check logic was to curl the endpoint and see what the status code is, when you get a 200, you will exit with 0. And that's actually a common pattern when it comes to Chef Habitat and health checks. An exit code with status 1 is warning. So if you had a telemetry endpoint that had different sets of data, and you could see that the resource usage is very high, you'd be able to actually parse this data in the health check hook, and through a basic set of criteria, you would be able to say that it's going to exit with a status code of warning, or alternatively, when it goes beyond a certain threshold, you could say that it is critical. If you are exiting with 2, this is a critical status code. We're going to be making use of this today. And this is if your application is not working at all. The last possibility is unknown. So if you exit with 3, you would say that you're not able to actually properly gauge the health of the service. And in this particular case, let's say you have a health check endpoint, and part of the Habitat package's configuration is the endpoint for the health. Let's say that gets misconfigured, and in your health check hook, you get a 404. Then you would want to exit with unknown because you misconfigured it, and you're not able to properly say what the health of the service actually is. So we're going to delete that for now. We're going to add it later once we actually have something to go on in terms of getting the health. Because right now, all our application is doing is saying hello world. As we mentioned before, if we had a health endpoint or a telemetry endpoint, we'd be able to use that in our health check hook. However, right now, we don't have even a health endpoint. So we are going to leverage something in the Golang ecosystem in particular a library made by ShuttleOps called HealthCheck. And this library is useful for people who are creating services that are going to be in Kubernetes. It borrows two concepts. One is liveness checks, and one is readiness checks. In Kubernetes, a liveness check is simply what is the health of this particular service right here, right now. And so let's say the service reaches a deadlock, your liveness check should fail, and then the orchestrator would restart it. A readiness check is whether or not the service is actually ready to begin serving. So any upstream dependencies, such as a connection to a database that are not yet satisfied, when the container in that pod, and this is in the context of Kubernetes, when it is coming up, when it's not yet ready able to connect to the database, the readiness check is failing. But once it is able to, it'll start passing. So traffic will be routed to that particular pod. We are going to use the liveness check concept here because it is more basic. In our particular application, we don't have any telemetry logic. We don't have a reason to exit with warning or anything. In fact, we don't even have a reason to exit with a failed health check. Our health check hook is always going to expect the health check endpoint to be up in our service. And if it's not, then we're going to exit with 2 in the health check hook. But here in our Golang binary, if the health check endpoint is available, if it is serving traffic, it is always going to exit with 200. And so what we're going to do is we're going to instantiate the handler for the health check library. And as we mentioned before, we're going to be using the liveness checks. So we're going to add a liveness check. I'm going to name this liveness. And here we are defining if it's going to exit with an error or if it's going to exit with no error at all, and hence return a 200. So here it's just going to return nil, so no error. And in order for it to serve, we're going to add a go routine. And we're going to listen and serve on port 8080. I'm just going to hard code it for the sake of demonstration. And now, if we were to build this, in theory, when we run the Golang binary, it is going to listen on port 8080. And when we hit the liveness endpoint, it is going to return 200. So from the Chef Habitat Studio, let's execute build and see what happens. We can see that our dependency Go, which is a build time dependency required for us to build the binary, is currently being downloaded. And as we saw in our last tutorial, the implicit dependencies that Go requires are now being downloaded as well. And the build has started, and it's failed because our ShuttleOps health check library is not available in the Go path. So if you've ever used Go, you would know that we do need to do a go get. So let's add a go get and try again. And we can see that get, which is a binary that is required by Go when it's doing its go get, is not available. So what that means is in our build time dependencies, we're going to add get. Here we're going to try again. We can see that core get and its implicit dependencies is now being downloaded. We can see that it's building. Clearly, it's downloading a package. In a second, we're going to see what the result of this is going to be. And we can see that it failed. So there is a very specific issue that happens here. it is complaining about the install location for this particular directory and that it's outside of the Go path. There is a simple fix that we can do here, and we're just going to export a variable called GoBin, and it's going to be our Go path / bin. So Go path is a variable that's actually handled by our dependency, our built-in dependency core / go. So we don't need to worry about defining that. We just need to reference it here when we're defining GoBin. So let's try again. It is building, it is downloading the package again. And we can see here that it's successfully built, and it is now generating the final artifact. Let's source our last_build.env file. And let's do a habsvc load of the variable that became available when we sourced the last_build.env file, which is package ident. And let's force it. Let's keep that in our bash history when we iteratively develop. And we want to use the force flag so that it unloads the old service and loads the newer one in its place. So let's just do that. And let's look at the logs. We can see that our Hello World app is doing what it needs to be doing. And we want to find out if indeed it is listening on port 8080. Netstat is not available because we don't have that binary, but we can do a hab package install of core basebox. And basebox is an implementation of core Unix utils, including netstat. So we're going to install core /basebox, and we're also going to add the -b flag. The -b flag means we're going to bin link and ensure that the binaries are available on our path. So we're just going to do that. So let's try using netstat again. And we can see that it is indeed listening on port 8080. We want to curl. And we can see that curl is not available. So we're going to do the exact same thing here, but with curl. And we see that we did get a response on the liveness check. Let's just see the status of that. And we can see it's a 200. And that is exactly what we wanted. And now we're able to start building our health check. Now that we have our health check endpoint, we are able to start creating our health check hook. So we're going to create a file called health check that sits next to the run hook. Again, it is going to be a bash script. And we're going to make use of curl and use the -w flag to read the status code or to write out the status code. And we're going to direct the output to dev null and suppress any additional output. So all we get is the status code. If I run that in the studio, I'm going to show you what that looks like. As you can see, all I wrote out was the status code. So that's exactly what we wanted. We're just going to make a variable we're going to use later on. And we just need to make sure that this status code is indeed equal to 200. As we said before, 200 means that we can exit with 0. So we can exit with OK. If that is not the case, then we can exit with 2, which is critical. So just by having this file, we are now able to make use of health checks. The important thing here, though, is we are using curl in our service. And that is not defined as a dependency here. But it's not going to go here as a build time dependency. Instead, we're going to create a list of runtime dependencies. Before, we didn't have that because Golang was able to create a binary, which we didn't need any runtime dependencies for. But this is going to be our first runtime dependency, curl, and we're going to build. You can see that curl is being downloaded for this package. Our final artifact is being created. And in a second, we're going to be able to source the last_build.end file and load the new package ident. Again, we can see our hello world working as intended. And we are also able to find this health check in our hooks directory. When the service is loaded, you have the /hab/sbc/service name. So all loaded services have these directories here. And we can see the hooks. So once we executed the bash script, we can check the status it exited with. We can see that it's 0, and that's exactly what we wanted. Because as we've said before, this is going to be, in the Unix world, a status code of 0 is, of course, a good thing. It is successful with no error. And with Chef Habitat, when you exit with that status, that translates to OK. So let's curl the Chef Habitat endpoint for the services health check. So if we do, if we curl the port 9631, which is the HTTP gateway for the Chef Habitat supervisor, /services, and then the name of the service, Golang Habitat Hello World, the service group, which is default. We're going to append that to /default to the name of the service. And finally, health. This is going to give us the health status. And here we can see that the status is OK. And this is exactly what we wanted. So hopefully that shows you how to create a health check for your Chef Habitat package. Now that you have a health check, you are able to commit this upstream to a repository connected to a build pipeline in ShuttleOps. And if you connect that build pipeline to a deployment pipeline, you can provision this as a component and monitor its health through ShuttleOps.